Assalamualaikum and good day. Today we're going to present about our piezoresistive sensor, which we choose a pressure sensor. We are from group MEMS 18. My name is Muhammad Syaiful Aizat bin Muhammad Azhar.
My name is Dr. Fitri bin Khairuddin.
My name is Ahmad Azhar bin Tajuddin.
Going on to the first slide, we're going to explain about our layout.
Okay, so figure 1, this is cache refer for our project. For figure 2, this is our expected simulation for ANSYS. The operating principle of the design MEMS piezoresistive pressure sensor is based on the deflection mechanism of the membrane using parallel plate capacitive configuration. As you can see, there was two pressure equations that we put, which are maximum stress and maximum deflection. For sensitivity equation, S equals delta U over U in times with 1 over P. Okay, next. First, we create our layout in MEMS Pro. As you can see, this is our full layout view and scatter view. For the material database, we use silicon, aluminium, silicon nitride, boron, silicon dioxide, and pyrite glass. We use 22 layer in box shape and we use 1 layer in custom polygon to create our layout. Okay, next. We create, this is our process definition and 3D model that we simulate in MEMS Pro. Firstly, we create substrate wafer by using silicon. Then we deposit silicon dioxide at top and bottom wafer. Then we etch silicon dioxide inside mask layer. Then we implant boron and aluminium at the surface that we already etched. And next step, we deposit silicon nitride at top and bottom layer. Then we deposit silicon dioxide at top and bottom layer. And then we use reactive ion exchange and we create small square shape at top layer of wafer. And then we deposit aluminium at top of wafer to fill in hole that we create in reactive ion exchange process. After that, we etch aluminium outside of the mask that we already put at top of layer. And next step, for step 11, we etch the bottom layer to remove silicon nitride and silicon dioxide. Then we etch again at top of wafer by using custom mask of polygon shape to create a chamber. Then we etch top layer inside the mask that we already placed. After step 13, we use wafer bonding method to add pyrite glass at bottom of previous wafer that we create before to seal the chamber. And then as you can see, this is our final cross section and the final 3D model.
To test our design, we have converted our 3D project previously on MEMS Pro into .igs file to be simulated in ANSYS Workbench. The test that we are about to conduct is the sensitivity test on the sensor to see its working mechanism and their strain test on certain way. While working on our experiment, we have counted some error which stop us from continuing further. Most of our project are only halfway. As we can see in the figure where the geometry's only surface is shown. There are supposed to be a total of 6 solid body to be shown in the geometry section instead of surface body. The surface body that is shown highlighted in the figure contain various other body which need to be corrected. Working on the surface correction of our layout, we have opened the layout to edit the geometry in the design modeler in the space claim extension provided by ANSYS software. Upon opening, we have discovered about 297 surface layer that need to be recombined into a solid body. In design modeler, we have already selected individual surface to be combined into one solid body by using create body operation. At the type section, we choose seal and we merge the body Then we click apply. However, we are unable to merge the surface into one solid body to be shown in our model. Various methods has been done and research to obtain and reattach to gain the solid body. As staged in space claim also has been done. However, it's further complicated our design to more ununderstandable form to be edited, such as weird shapes, such as from the original layout when the shape with round edge is combined together. As we can see there, we show the error encounter table, and the bottom figure we shows that 4 single plane of layer that is meshed together without any edge. In conclusion, we conclude that the error is occurred due to the file that we convert, which is the .igs file from the MEMS Pro software. Due to our lack of knowledge and experience, is also the main cause that we are unable to proceed our experiment further. Many other options, such as reopen the project and inserting our IGS file, has also been done, but it's also giving the same correction error output for our project.
With that said, we believe that the MEMS piezoresistor sensor is a good sensor that could improve our campus sustainability. One of the ways it could improve campus sustainability is by its recycling and garbage disposal. Recycling is the process of converting waste products into usable material. It could reduce the amount of waste disposed in landfills and save natural resources. Many campuses around Malaysia practice recycling and other waste disposal methods. However, the methods of waste disposal or recycle used by these campuses are mostly problematic due to the garbage collectors' fixed schedule, their daily routine. The recycle and garbage bins around campus area could easily overfill, which causes garbage leaks that are unhealthy for the community. By using the MEMS piezoresistor sensor, we believe that we could create a sustainable waste disposal service that could save a lot of time and resource. By utilizing MEMS piezoresistive pressure sensor, we could create a better and more sustainable waste management system. The way the piezoresistive sensor works for the, as we call the smart recycle management system, is by placing the sensors on the bottom of the garbage bins. This sensor would then take the pressure of the garbage. After these sensors reach the pressure limit, it would then send signal for garbage pickup. We believe that this system would not only reduce costs and resources, but it could also reduce many kinds of pollution. We also believe that the smart waste management system would follow 3 of the United Nations Sustainable Development Goals. The first one being the SDG 11, which is Sustainable Cities and Communities. With our smart waste management system, we could create a more sustainable community inside the campus, improving our resource use and reducing pollution. The second goal would be SDG 12, which is responsible consumption and production. Our aim is to provide an easier access to a greener and healthier environment, while also we want to give a better quality of life in terms of waste management. That is our goal for SDG 12. And our final goal is SDG 13, which is climate action. We want to take an action on climate as we make recycling easier with our smart waste management system. We indirectly reduce pollution and emission, thus making a cleaner and healthier environment.
That's all from us from Group MEMS 18. Thank you.